Hello, thank you for joining us for today's program. My name is Joe Campbell, Director of the Environmental Professionals United States. I'm providing these welcome comments in lieu of Dr. Jeff Sharp, Director of our School of Environment and Natural Resources. He provided these comments in the original program. However, those comments were lost during recording. We want to thank you for joining us for what is EPN's first online monthly breakfast program occurring through a webinar-based format. We appreciate you tuning into this program, as we know at this current time, things are a bit chaotic and unpredictable in our lives and in our family and in our careers. This morning, we continue our celebration of water issues here in the state of Ohio in the month of March. The Environmental Professionals Network and the Water Management Association of Ohio, pronounced WMAO in acronym form, have worked together over several years this month to highlight particularly relevant issue facing the state of Ohio in the field of water and water management. This is our second consecutive year working directly with the Ohio Water Resources Center and TerrAqua, a multidisciplinary Ohio State student organization, to develop this program. The Ohio Water Resources Center is the federally authorized and state designated Water Resources Research Institute for the state of Ohio. I want to specifically thank Linda Weavers and Zuzana Baharova for their support and contribution in the development of this program. I also want to give a special shout out to Dana Oleskowitz with WMAO and Karina Pegow with the Bird Center, who, along with Eugene Bragg, board president of WMAO, who you will hear from in a minute, as well as Hannah Commune, student president of TerrAqua, along with several other students who are from TerrAqua, for working with Nicole Jackson and I here at the EPN to develop this program since August, when the students first arrived to campus of this academic year. On the slide featured here, you will see we have sponsors for today's program that we'd like to acknowledge. We'd like to thank Fishbeck, Pickett Enterprises, and Terracon for their support of today's program. We look forward to welcoming you and your teams to a program on campus in the next academic year. Thank you for your support. As I was saying before, the WMAO, EPN, Ohio WRC, and TerrAqua team members initially designed this program starting way back in August of 2019. And our intention was to create a 4-hour extended educational event that would include both a breakfast and a longer dialogue, in line with World Water Day's 2020 theme of the interactions between water and climate. We've condensed that 4-hour in-person program into a 2-hour webinar that you will see now. There will be, throughout the course of this webinar program, interaction between those who are panelists in the program and the panelists who will be answering questions throughout. You'll be able to follow that both through some of the spoken comments that will begin around 10:20 a.m. in the program, towards the end of the program, as well as throughout in the chat and in the Q&A box that is available. Turning to today's program topic, our team identified an opportunity to develop a networking program among water experts, young professionals, and general audience alike that aligns with the World Water Day topic of the interactions between how climate change is impacting the water cycle, and to, importantly, review strategies on how to communicate these interactions to various audiences, including those working actively in natural resource management and to water resource users. We are excited to be bringing in experts into the program today that represent some of the best science we have, both at Ohio State in this field and from that school up north. Eugene Bragg will provide a brief introduction of our set of speakers shortly, and bios for our speakers are at our program site online. Under normal circumstances, our EPN breakfasts are a unique and excellent opportunity to give students in-person professional development experience on some very relevant and real-life environment and natural resource issues, and a chance for working professionals, retirees, and other interested community members to connect directly with students and with one another. Precautions surrounding COVID-19, the students will not be participating in in-person networking activities for the remainder of this semester, spring of 2020. Any of those students who are joining us today online are doing so at their own leisure, as we are now in a second extended week of spring break here at Ohio State. We are proud to feature one student on this call today, Hannah Commune, who along with Riley McDonald and other members of the TerrAqua student organization have been contributing to the development of this EPN program since August. Hannah Commune is a junior studying environmental science with a specialization in water science. She is the current president of TerrAqua and represents the student organization on Sustainability Council. In addition to TerrAqua, she is a student instructional assistant for a community environment development course that I teach and is helping to advise a new student organization called Ecosia at Ohio State. Hannah is from Canton, Ohio, and that is where she is joining the call today. I will hand it over to Hannah and thank you for your efforts to join us remotely.
Hi everyone, I'm so happy to be here representing TerrAqua today. For those of you unfamiliar with TerrAqua, we are a student organization within Ohio State School of Environment and Natural Resources with a focus on water quality conservation and professional development. We are also a student affiliate of the Water Management Association of Ohio. We have a variety of events every year, such as trainings to become Ohio EPA certified data collectors, lab tours led by SC&R faculty and graduate students, and presentations focused on career development. This summer, we will begin our yearly CLAM sampling events, and CLAM stands for Citizen Lake Awareness and Monitoring. At our CLAM events, we take measurements to assess the physical aspects of water quality, such as temperature, depth, color, and turbidity. This is one of my favorite events that TerrAqua puts on, as students are able to continuously utilize these data collection techniques in field-based classes, summer internships, and even beyond their time at Ohio State. TerrAqua addresses dynamic water resources and climate change through water quality monitoring and citizen engagement. We believe that we should focus on not only trying to understand the science behind what is happening to the planet, but also how to effectively communicate what is happening to one another. Through collaboration with professionals in the field, we are gaining the knowledge needed to best educate others about the importance of protecting our water resources. To conclude my intro for today's program, I wanted to talk a little bit about TerrAqua's advisor. Now, I have known Eugene since I was a freshman, and he has never once failed to put a smile on my face. He has helped organize numerous events, facilitated networking opportunities, and given words of encouragement throughout all of our endeavors. I have so much admiration for Eugene because of his ability to communicate science to others. I can't imagine my experiences in TerrAqua without him. Please welcome Eugene Brigg, Program Director of Aquatic Ecosystems and President of WMAO.
Thank you, Hannah. You caused me to blush. If I'm to be honest with myself, I would really have to admit that mentoring students, especially through TerrAqua, has really been the most rewarding part of my 2/3 done career. Welcome to the not quite as expected annual joint mini conference of the Environmental Professionals Network, Water Management Association of Ohio, or WMAO, and the Ohio Water Resources Center. My name is Eugene Brigg. By training, I'm a fisheries biologist. As you've heard, I now serve the state as Program Director for Aquatic Ecosystems with OSU Extension. I'm also the current president of WMAO and have served as the advisor or co-advisor of TerrAqua for nearly 20 years. WMAO's history extends back nearly as long as I've bothered to be alive, nearly 50 years. We've become a kind of umbrella organization. Personally, I came to WMAO through my interest and activity with OLMS, or the Ohio Lake Management Society. However, WMAO comprises 5 similar divisions and multiple diverse interest areas. Any professional whose interests intersect the management of water could benefit from affiliation with WMAO. I encourage you to visit our website for information. Also, feel free to contact me directly with any questions about the organization. It was TerrAqua's interest that prompted WMAO to create a mechanism to recognize student organizations in autumn of 2014. And TerrAqua became our first affiliated student organization early in 2015. As president, it's one of my goals to expand student representation within WMAO, to reach out to student organizations that have an interest in the issues associated with water and its management at other colleges and universities in the state of Ohio. Students or club advisors, again, please feel free to contact me directly or through WMAO. I'm willing to guarantee 2 things this morning. First, that our global pandemic will eventually be behind us. Associated societal stress will diminish and the business of humanity will resume. Second, when it does, every human being will still be made up of mostly water. That is, water is vitally important to the well-being of every person. World Water Day was created by the United Nations to call attention to this vital importance. The official observation this year falls on March 22nd with the theme Water and Climate Change. Today's program deliberately mirrors that theme. Changing climate, of course, will change the budgets, either or both substantially or subtly or dramatically, of how water behaves on the landscape. Changing climate has potential to exacerbate problems associated with supply or access to water, water level changes and impacts on coastal areas, aquatic invasive species, the frequency and duration of harmful algal blooms, the management of stormwater in the human environment, and myriad others. To address those issues and their communication, we have assembled an impressive and exciting panel of expert speakers for this morning's program. So first, Dr. Brian Mark received his PhD from Syracuse University and now heads the International Glacial Environmental Change Research Group affiliated with the Bird Polar and Climate Research Center at The Ohio State University. I encourage you to read more details of his biography on the webpage for today's program. Dr. Mark.
Good morning, everybody. It's a pleasure to be with you. I'm going to share my screen here. Okay, so what I'm going to do today is share the time with my colleague, Mike Durand, and we're going to just give an overview as to what's going on in the cryosphere. Now, the cryosphere, we just want to orient you all, is, of course, a major component, a critical component in the Earth system. But what I want to do, and my message is kind of simple, I want to just give an overview of where the cryosphere is in this changing climate and how important it is, and then point out, just from maybe even a little bit of an allegory, an example of what management issues are like in a place where, in the Peruvian Andes, as you can see in this picture, the melting cryosphere is impacting livelihoods, but it's doing so in a way that's not straightforward a water issue of volume only. Okay, so just to remind us all that when I say cryosphere, we're talking about frozen water. So water in its solid phase. And this, of course, is Earth's largest freshwater reservoir. So if we look at the oceans, 97% of the volume of water on the planet, we might as well call Earth ocean if we really wanted to look at it that way. But of the remaining 3%, the vast majority is locked up in ice. And of course, most of that ice is in Antarctica, where we have something like I think it's like 14 million square kilometers of ice. But if you look at the seawater and the ocean sea level equivalent of this water, if this were all to melt, you can see that we're talking about 74 meters of sea level equivalents. The other big piece of ice, almost 10 times smaller really, but still massively important right now in sea level equivalent, is Greenland. Greenland's melting. It's changing phase, and it's adding a lot to sea level right now. It's now melting at about 6 times faster than it was in the 1990s. The issue when we look in the future as to what the sea levels will do, it really hinges on just how dynamic this ice is. And I would point you out in reference to our director of the Bird Polar and Climate Research Center, Ian Howitt, who's now a distinguished scholar at Ohio State University, for his group's research that really looks closely at quantifying the mass fluxes of Greenland and other areas of the polar regions. I also want to just point out that the IPCC's most recent report last year, they came out with a special report on the ocean and the cryosphere in a changing climate. This is a really important report that you can reference and read. I just threw up here a diagram and a quote. The diagram shows just how vital the water cycle is, not only for water resources and the phase change of the solid ice into liquid, but also to the flux of energy and carbon. So the oceans are the second biggest carbon reservoir after the sedimentary rocks of the planet. And as we shift around this water, it's really important as feedbacks into climate itself, but also into the carbon balance. And so the state of the ocean is vital. In fact, most of the added energy we're putting into the planet right now is going into the oceans. And so really we can say that all people on Earth depend directly or indirectly on the ocean and the cryosphere. Now, my fascination with the cryosphere is much more smaller scale. So I like to point out that mountain glaciers, if we add up all the area of glaciers that are mountains outside of the polar ice caps, we're looking at a lot smaller area of the cryosphere, but still about 5.5 Ohio's worth, distributed mostly at the high northern latitude. You can see just how important the North American component of that is, but Central Asia, Northern Asia, South America, we have a big ice cap, the southern Andes. But what we have been focused on mostly is low latitude glaciers within the tropics. Almost an oxymoron to say tropical glaciers, but if you get up high enough in the Andes, or also in, you can see there's a little bit left in Africa and Indonesia, we get conditions to sustain perennial ice and snow. And so I've thrown up here a histogram of world population by latitude to match those tropical latitudes. And this just shows just how these tropical ice masses, although they're small, are really closely connected to a lot of people. And globally, more people live within the tropics in that band than elsewhere. So the distribution of ice is not even on this planet. That's one thing we can keep in mind. We're globally linked, however. And when we start to think about the impacts of where that melting water is actually going, things get a little bit more complex. But it is fair enough to say that just like the global Earth getting warmer, we're melting ice, we're phase changing, the mountain glaciers themselves are receding quite a bit. And so we can look at iconic graphic photos of this and see how Glacier National Park might soon become Glacier-Free National Park. And this has been well documented by reports through the USGS. And you can just see it in this quick photo series, just how much ice is changing and how this landscape is changing. We can think about the implications beyond just the ice and the water. We can think about the ecosystems and the shift in land cover. We can think about organisms. We can also think about tourism. In the bigger glaciers of Alberta, you can see time photos like this from 1919 to 2005. And this is repeated in many different locations around the world. The largest ice that we have in our country is up in Alaska in the coastal ranges. So you can see here the McCarty Glacier from 1909 at the bottom in 2004. And just a reminder that Alaska's 25,000 glaciers will lose something between 30 to 50% of their mass by the end of this century, forming the largest global regional sea level contributor in the Northern Hemisphere, apart from Greenland. Our group in the Bird Poll and Climate Research Center, looking at lower latitude glaciers, has been to Kilimanjaro to chart the loss of ice here. Here's a photo, aerial photograph from 1950, and then again in 1999. And the famed snows of Kilimanjaro are melting. There's a photo of our group there in 2006, mapping the remaining northern ice fields. And you can see the bottom left photo, there's Lonnie Thompson by a sliver of ice. This might be what the last part of Kilimanjaro will look like. And then the small, tiny piece of ice left in Indonesia is over here, photographed in a recent publication that just came out this year, just charting how quickly this ice mass is disappearing. And you can see the photo series on the right from 2010 to 2018. And Lonnie Thompson was able to get an ice core in 2010 and put in a stake all the way through to see how just much that ice mass is being lost, not only in aerial extent, but the three-dimensional volume picture. And so for me, when I did my dissertation, I started back at the end of the last century and was able to see a similar retreat over the recent years in small mountain glaciers in the Peruvian Andes. The Peruvian Andes hold more tropical ice than anywhere else on the planet. And so here's just a photo series again from 1998 to 2015. And what we've been able to do is quantify the total volume loss here. And these, when you just look at aerial images or satellites, you don't capture the full volume loss because you're not seeing the three dimensions as well. But when you quantify that, a lot of volume has disappeared. And so my group has coupled an inquiry into just thinking about this melting ice to think, well, just how much does this impact water resources? And this becomes a tricky question that you really can't answer with just quantifying volume shift in glacier volume. You have to think about where that water is going downstream, who's using it, and how you get access to it. So we've tried to establish a transdisciplinary approach to look at this by coupling our inquiry not only with physical science, but with social science, and going into the field at the same time and working with stakeholders to try to appreciate their perceptions of change. And what I can show you here in this overview map is that the Cordillera Blanca holds more tropical glaciers than anywhere else on the planet. It's right in the central Andes of Peru. And if you look at the water that drains that mountain range, it goes down through the Santa River to the dry western coast of South America, which in Peruvian terms here is a desert for most intents and purposes. But with all the extra water coming down, we've been able to establish a whole development of agriculture along this desert coast because of irrigation. And you can see the Madre Canal, the Mother Canal, and the photo on the left. And on top, upper left, is a bunch of asparagus. Peru has now become the largest exporter of asparagus, and that's grown largely in the desert. So what we've thought long and hard about is this question of, well, where does the water go? First of all, how much is coming from the ice versus other systems? And that's taken us into the groundwater. But it's also started to reveal lots of interesting patterns of that water-rock interaction and water quality. And the emergent reality for water management is one not only of volume, but of water quality and where that water is and in what condition when people are using it. And of course, when we think about the whole system of what set up the economics and dynamic response socially to establish a global market for asparagus to be grown and exported from the desert coast of Peru, irrigated by water buffered by melting glaciers, which are melting because of global warming, we're into this really interesting reality that the watershed no longer is the unit of analysis that really contains all of these variables. So there's a lot of interesting feedbacks to think about. It's a very complex biophysical and social situation of water access. And if you just look at some of the statistics of where people are accessing this water, we might think that those people up close to the melting glaciers have most of that water. Well, they actually have too much water, and they actually have it sometimes in a precarious, hazardous condition. And so when we look at the agricultural production, the crops that have really grown in recent years, this is agricultural production from 1960 to 2010, shows how the traditional agriculture of potatoes, of barley, of wheat, and alfalfa have all decreased in relative growth compared to this massive expansion of things like sugarcane, asparagus, and rice. So that's shifting in response to global market forcings. When we think about the melting ice providing this nice buffer of water for irrigation on the coast, I mentioned up closer to the glaciers, there's a hazardous reality of living below these melting bodies of solid water becoming liquid water behind loosely consolidated moraine dams that are then subject to tectonic forces and often let loose in these massive outburst floods. And so this continues to be a hazard. There's a massive lake above the biggest population in the Cordillera Blanca, the Huaraz, is the capital city of the province. And there's this lake called Palcococha that's being drained and siphoned by big pipes because the water levels are creeping up above what's a safe level on the moraine. And if there's another ice avalanche into that lake, like happened in 1941, the whole city could be threatened. So I mentioned that coastal irrigation, just to show you the numbers here, how much hectares have really expanded in their irrigation from 1958 to 2004 through various different irrigation projects. This has really been an exponential growth of irrigation capacity, really to the tune of about 85% of the river discharge is now being derailed into these pipelines and moved across multiple different watersheds for people to access. And that infrastructure is premised on having the right amount of water at the right time and controlling it and controlling that water quality. This is a huge investment. There's a lot of people that are getting jobs out of this, but you might also consider just who those people are and how mobile and agile that population is, or how resilient they might be for changes in that water level. There's also a lot of hydroelectric capacity that's being tapped. This is a high energy environment as that water moves from the high elevation mountains back to the coast. And this is also expanding. But as I mentioned, this infrastructure and this access question is really premised on stable, abundant water that can function well. And as we lose the glaciers, there's less and less of this clean, clear water, and it becoming more subject to the rain and erosion and sediment loading. And so already the turbines are having to be changed much more frequently in these run-of-course hydro plants. And they've had to do a lot of other treatments to get the water in condition for use. Meanwhile, demand for energy has continued to grow. And so there's a really complicated graph to depict a decrease in discharge accompanied by an increase in variability of discharge. And this is what's happening as you lose the base flow buffering of the melt from glaciers, which act as a nice reservoir and hold back that water and release it slowly in the dry season, superimposed with more capacity in this hydropower graph, just showing you this one proxy for demand. And the other reality in this catchment that you can see in the graph on the right is that this whole 12,000 square kilometer watershed, half of it is now under mining claims. And mining has its own complicated issues with water quality because a lot of traditional techniques of processing the ore end up leaving the relaves or the residual mining waste right in the course of the river. So I want to summarize just by saying that when we think about this shift in water, it's not just a matter of the total volume that can be openly accessed. It's really a matter of where that water goes and who has the capacity to get it. And lowland populations far from the glaciers are therefore vulnerable to this climate change and ice loss, but vulnerable to many variables and not just the glacier shrinkage and the climate change. So it's much more complex and nuanced than the simple apocalyptic scenario. We're not going to lose all the water, but we're going to have a different access seasonally and in water quality. So approaches from water issues from an integrated perspective that really take into account this hydrosocial cycle or the socio-hydrology. All these terms are becoming more relevant as we think about the integrated nature. Furthermore, the virtual water demand of that ag export really redefines a watershed on a global scale. So to summary, we could say really that water cycling moves water between phases on Earth, responds to global forcing, but has a lot of local variability distribution. Most of the fresh water is in ice on the planet right now. That is melting. That increases a lot of opportunity, but it also risk. Even as this demand is growing, the access to that water is not even, and is contingent upon complex interactions between human and natural systems. So in this warmer world we're facing, the fluxes are also going to change, altering the patterns of precipitation and evapotranspiration. And you're going to hear more about what that means at a local scale from the rest of our speakers. But now I'm going to pass the hat to my colleague, Mike Durand, to tell you a little bit more about the frozen world and its shift in phase. Thanks a lot.
That's great. Thanks, Brian. Yeah, so I'm going to pivot just a little bit and continue with the theme of the changing cryosphere and the Earth's water cycle, part 2. And we'll now be talking about how these issues affect things in mostly with regards to snow, and then mostly with a focus on the Western United States. And as motivation on the left here, we've got a photo of Lake Mead, a critical reservoir on the Colorado River. Snow is an important part of the water cycle, not always often appreciated. About 1/10 of total terrestrial precipitation falls as snow. We have strong reason to believe that that's an underestimate. For example, if you look at where the snow is located, kind of continuing with the theme that Brian mentioned, if you look at where snow is located and how that affects people, this is a really clever study done, over a decade ago now by Tim Burnett He compared model output of stream flow and snowfall, and then made a ratio between the two of them. And am I actually sharing? I'm not sharing, am I? Sorry about that. Okay. Here is what I was talking about earlier. Approximately 1/10 of global precipitation falls as snow. I'm gonna make sure, hopefully someone will send me a chat or a text if any of this is not working correctly. Okay, so like I said, the importance of snow can better be seen by this global map, which shows that if you identify locations where that snowfall to runoff ratio is over about 50% as places that have snow-dominated hydrology. That covers 1/6 of the global population and even larger percent of the global economy because of where population centers are located. Importantly, and as a theme that we'll see in the rest of the talk, if you look at the little inset there with the red areas are places of complex topography where it is very, very difficult to get good spatially continuous information about snow water equivalent. All right. So zooming in a little bit to the Western United States and talking about something our group contributed to this problem. It has been said for decades that about 2/3 of the stream flow or so in mountainous areas of the Western United States originates with snow. But if you trace those citations back, you find that this literally was something that a water manager who knew what he was talking about said at a conference in the 90s. But while he had an intuitive feel for this metric, he'd never actually done a study to estimate it. And so this had just sort of crept into the citations, one person citing another until this had become gospel. But in the meantime, no one had ever checked it. So our group found a way to check it and found that it's not actually quite true to say that, in fact, it's a little bit less than half of runoff over the entire West because of places like Seattle, Washington State, Oregon, where there's so much rain dominance. So what we did was map this ratio of the total fraction of stream flow that originates as snow. We checked it with isotopic measurements and found that over the Western United States, this our community's intuition is correct. It's about 2/3 of stream flow originates as snow. And this is really likely to change dramatically in the future, especially in mid-latitude areas, California, and as well as the Cascades, where snowpack just sits right at the melting point all winter, and a small change in temperature can really shift things dramatically. And now some of what I wanted to talk about. If you look at Northern Hemisphere snow cover, this is similar to what Brian was showing. Snow is changing quickly. The snow albedo feedback loop, as we often talk about it in kind of global climate studies, is where we lose some snow cover, and then by exposing that the ground underneath the snow earlier and earlier in the year, that ground absorbs more sunlight, absorbs more solar radiation, thus heating the air and warming the air, and then melting more snow, and then heating the ground more, and so that's a part of the feedbacks in the global climate system. And we are seeing this happen very quickly. So this is a paper by Ross Brown, Chris Dirksen, a number of years ago, showing that June snow cover extent across the Northern Hemisphere is decreasing quite rapidly. We often use the September sea ice extent in the Arctic as one of the main climate metrics. And in this paper, they showed that June snow cover extent is actually changing much faster. So we know we can see snow cover extent change from space. We can get a fairly good handle on that. What we have more trouble measuring and understanding globally, and even at the scale of the Western United States, is what that does for water resources. The Western snowpack is what I'm going to talk about for the rest of the time here. Colleague Matthew Sturm, a couple of years ago, set out to try to quantify how important financially the Western United States snowpack is. And to their surprise, when they've enlisted some economists, the present value of the snow is something past billions of dollars. And so his paper title is Water and Life from Snow, a $1 trillion science question. So we teamed up with Matthew Sturm. We took the map I showed you earlier, which showed what fraction of stream flow comes from snow, and then worked with the economists there to map the prices per acre foot of snow. And this is this interactive tool. You can find it at the web link there in the bottom. And you can click on each region in the West and see the percent of runoff that comes from snow, and then how much that is worth financially based on different water prices. I want to stress that in the out west, the snowpack is not what it looks like here. Snow is usually an annoyance here in central Ohio, and most of the, for example, in the Great Lakes region, all the Lake Erie watersheds, we're usually thinking of snow as something that's annoying. It doesn't last that long. It's here for maybe a week if we're lucky. I think of it as good luck when we have snow on the ground. Though of course it snarls traffic and leads to injuries and so on. So it's a nuisance for us. Out west, it's completely different. I just mentioned how important it is for the water resource picture. It's also lasts all winter long. So we have a seasonal snowpack, and you can easily find places like this. This is a 250 centimeter snow pit. If you want to see lots and lots of these, follow Dr. Mackenzie Skyle, who's a professor at University of Utah. This is a 250 centimeter 8-foot pit, which I have also been in these. They are quite something to see, and we always admire Mackenzie's amazing sharp corners that are more right angles than anything in my house, that's for sure. So in order to understand how snowpack's changing, there's a number of amazing resources. And they go back fairly far back, actually. So these are photos from like the 70s from the NRCS. And what folks do is they measure snow water equivalent. So measuring this quantity in the snow pit, as you might imagine, you have to dig all the way down. It takes a long time, so we use a tube, insert it all the way down through the snow, and then weigh it, as is shown in the photo on the right there. And when you look at snow courses across the western United States, you see that the value on April 1st, which traditionally has been a climate metric, a metric used to calibrate how much water is available at the county level, at the water agency level out west, these have changed really dramatically. So the graphic on the left, each one of those is a snow course where these measurements have been made over many decades, and the big red circles are places where that April 1st values dropped by as much as 80%. This is work by Phil Mote, and the recent update, which I'm showing here, is from last year. You should check out the paper, and it updates one from about 10 years ago, just showing that things have continued getting worse and more dramatically worse over this time. And these have been reproduced by a hydrological model, as is shown on the right. I wanted to mention one particular place where these changes have major implications at the national level, and that's the Colorado River. I showed that picture of empty or drying Lake Mead on the title slide, and there's been a number of papers over the years that have tried to understand what warming will mean for runoff in the Colorado River, flowing into Lake Mead and Lake Powell, and supplying water across the West, mostly for agriculture, but also for cities. I think it's a pretty commonly known that the Colorado River no longer reaches the ocean at all. The United States and Mexico uses every drop before it gets to the ocean. So it's fully allocated. And just recently, you can see the publication dates from 4 days ago. In Science, Chris Milley published something that refines our knowledge of what is going to happen in future years to the Colorado. So Chris and Kristen estimated that the discharge of the Colorado, the average flow of the Colorado, is decreasing by almost 10%, 9.3% per degree Celsius of warming. That is very bad news. So the Colorado River is already oversubscribed. It was sort of apportioned out to the various states over a particularly anomalously wet decade or two. And so they use the stream flow, those wet years, to determine what every state gets. And now, not only was that an anomalously wet year in terms of precipitation, we're also warming and losing this stream flow simply due to a shift of that precipitation ultimately running off into rivers to evapotranspiration going to plants. And so this has important implications across ecosystems and also across water delivery and political and economic implications. So it's something to keep an eye on. So I wanted to mention that in addition to the water resource issues, of course, climate change and warming threatens winter sports industries, which are major economic parts of Western communities. And so organizations like Protect Our Winters, POW, are advocacy groups that are trying to push for climate action with the perspective of protecting winter sports. So what I've said so far relies on in situ measurements that are by almost design non-representative of the landscape. So you might cite for example, you'll probably try to cite a snow course or another resource, snow pillows, that I haven't talked about, in particular locations that don't represent slopes and trees and other parts of the landscape. And furthermore, they're concentrated in developed areas where we need to know how much snow there is for water resource issues. Trying to understand the world's snow is the kind of question that NASA is excited about. And so we've been our group's motivation is to understand that our global knowledge of snow is incomplete, and then it's important to understand how this picture looks across large landscapes. And so I'll mention just two things that we're working on. One, Melissa Regin, who is a former PhD student of mine, showed the global climate models that are used to understand, how water is changing across the largest scales. Often underestimate mountain snow, we believe, by as much as 2/3. So if you compare the blue and the green lines in that picture on the right, shows what a globally available estimates of snow water equivalent look like compared to what we think is closer to reality in the blue. So just question is, what does that mean for the rest of the global model? And then remote sensing, we currently don't have great ways to measure remote snow water equivalent from remote sensing. How much snow is actually on the ground. So SnowX is an experiment funded by NASA to work on testing methods that you could put on a satellite eventually that would give you how much snow water equivalent there is globally. And so here are some pictures from a field campaign I was on last month in Colorado, in Grand Mesa. So there I am in the top left with some of our lab's instruments, microwave radiometers, and the picture there in the center is a student from Colorado using one of our instruments to measure snow-specific surface area. And then on the bottom right, it's a picture of one of the instruments that we're testing. So in summary, snow is a critical part of the water cycle or water resource portfolio nationally, especially in the Western United States. Climate change is changing what our winters look like, and snow is melting earlier and likely reducing available water sources. So we need better understanding of global snow water equivalent, and SnowX is one way that NASA is pushing to get there. Thank you very much.
All right, thank you, Mike, and thank you, Brian. And thanks for everyone who's on the call now. We're going to transition to our next speaker. Kim Channel is joining us from the University of Michigan, the Great Lakes Integrated Sciences and Assessment Center. we're very lucky that Kim is able to join us remotely. And actually part of the way we were setting up her talk from the very beginning of first talking with Kim was to do a remote call-in to cut back on her carbon footprint and to sort of model what we're talking about today. So in fact, her comments are pre-recorded. So during her presentation, you won't actually see her picture, but she'll be speaking throughout, and then she'll be joining us at 10:15 during our Q&A. Her bio is going to be on the screen in a second. In the meantime, if you do have questions for our panelists, to please use the Q&A box to ask those questions.
Good morning, everyone. I'm Kim Channel with GLISA, the Great Lakes Integrated Sciences and Assessments. So today I'm going to provide an overview of climate trends in the Great Lakes region, some of which may have been touched on already by previous speakers. But I was asked to emphasize precipitation and stormwater and also give you a little background on a few stormwater related projects of ours. But I want to kick off with some background on GLISA first. So we are a NOAA-funded program housed at the University of Michigan and Michigan State University. GLISA is part of the RISA program, or the Regional Integrated Sciences and Assessments, which is a national network funded through the NOAA Climate Program Office. It's comprised of 11 different regional teams whose mission is to help build the nation's capacity to prepare for and adapt to climate variability and change. And I should note that we cover a lot more geographic area than this map says we do. So our service coverage actually extends to all of the Great Lakes states, not just within the watershed boundary. So GLISA works at the intersection of research and service to help bridge the gaps between science and decision making. By bringing research and practitioners together, we're able to build programs in a way that is usable, useful, and salient. We typically do this by tailoring our work and our data and information to specific locations in order to better meet end user needs. In doing this, we ask 3 specific questions. 1, what has happened historically? How has the climate already changed? 2, what will happen? What do the climate models project for the future? And 3, what are the impacts that we actually experience? And our ultimate mission is to help stakeholders, local officials, urban planners, policymakers, resource managers, and so on use climate information to make more informed decisions in the face of climate change. So when it comes to how climate information can help inform decision making, it's important to step back from the global scale terms that are so often used when considering climate change and look more at the regional scale and the local impacts, where we're going to be seeing changes in temperature, precipitation, seasonality, variability, and these regional changes cause impacts that are experienced at the local level, what we actually feel. And here, the degree of impact is more dependent on the ability to manage changes and adapt to them. We're going to jump into these regional trends, what we have already observed in the Great Lakes and what we're looking at in the future, starting with what's happening with temperature. Average temperatures in the region have increased by 2.3 degrees Fahrenheit on average since 1951, and are projected to increase by another 3 to 6 degrees by the mid-21st century, or about 2050. But the whole story isn't that simple. This doesn't just mean that in 50 years, June 17th will be 75 degrees instead of 70 degrees. This is just the average change. There are variations both spatially and temporally, and one of those variations is seasonal. So where the annual average temperature has increased by an average of 2.3 degrees, winter average temperatures have increased by 2.8 degrees. And I know that may seem like a very small difference, but when we're talking about differences in long-term averages over many, many years, that is a fairly significant change. And it means that our winters are warming faster than the rest of the seasons. And that means shifts in snowfall and ice cover and other things that we associate with winter. And to add another layer to this, temperature changes aren't even consistent between the land and the lakes. The lakes are actually warming faster than the air. Lake Superior has already observed twice the amount of warming than the air in the surrounding Superior Basin. And this is significant because water especially large bodies of water like the Great Lakes have very large heat capacities. So it takes more energy to change the temperature of water than it does to change the temperature of air. Yet water in the Great Lakes is still warming faster than the air in the Great Lakes. So this, combined with larger winter air temperature increases, has led to longer ice-free periods on the lakes. And this has impacts on the ice fishing industry, winter recreation platforms, wetland protection, and shipping and navigation. And still on the topic of winter, snowfall patterns have also shifted in the last 50 years. These images show the shift from the 1961 to 1990 average to the 1981 to 2010 average. So we can see in the upper part here along the north and west coast of Michigan, we can see that there's actually been an increase in snowfall in these. And that's to be expected because warmer lake temperatures and less ice cover mean that more moisture is available from the lakes for these cold air masses to pick up as they move across the lake, and this produces more lake effect snow. But then further south, where there is no lake effect, the bands of snow are shifting north, so each area is getting less snowfall, and this is generally because more winter precipitation is starting to fall as rain instead of snow as temperatures rise. The Great Lakes themselves do have a role in regulating our climate and affecting the changes that we see, and snowfall is a great example of that. And the timing of temperature change also matters. We're seeing shifts in the length of our seasons. The growing season, which is the length of time between the last winter freeze and the first fall freeze, has increased by an average of 16 days since 1951 and is projected to increase by 34 to 54 days by the end of the century. And this is typically because the last winter freeze is occurring earlier, meaning that spring is coming earlier. And if you look at these numbers, I mean, that looks like it's potentially 1 to 2 months longer that plants and crops could grow, but you have to remember there's going to be variability between the years, and we can't rely on this to be the case every year. And the benefits of a longer average growing season are typically outweighed by other factors like periods of drought and extreme weather. If everyone remembers last year's floods that really delayed the planting season, these are significantly more negative impacts that outweigh the little bit of benefit we get from a longer growing season. We're also anticipating increases in extreme heat days above 90 and 95 degrees by mid-century. And this can pose serious public health risks, especially to vulnerable populations who might not have access to air conditioning. But these effects are typically more locally focused than regional, because individual cities experience extreme heat more than the entire Great Lakes region would, which is why we don't necessarily have a Great Lakes region average trend to show you here. Though I do think you all remember last year's July heat wave that hit most of the basin pretty hard with temperatures in the 90s for several days in a row. So now let's get into precipitation patterns, because that's probably of the most interest to you all today. Annual precipitation has increased on average by 14% since 1951, but this is just the Great Lakes wide average, and there are both spatial variations and seasonal variations. So Southeast Michigan has seen a 17% increase in annual precipitation, while the western upper peninsula of Michigan has actually seen a slight decrease. The precipitation is just not changing in a uniform way like temperature may be, which is why it's so important to get locally customized climate information, because a precipitation trend in northern Wisconsin is not going to be the same trend in central Ohio. And where we see the most problems arise with rainfall is in extreme precipitation events. This is because these events can overwhelm stormwater drainage systems, cause flooding, close roads, and inflict property damage. The volume of rain falling in the heaviest 1% of precipitation events has increased by 35% in the Great Lakes region since 1951. The frequency of these events has increased as well, but to really understand increases in extremes, particularly rainfall, you have to zoom in on the local scale. So this map shows more local scale changes from individual station observations. So this map shows the percent change in intensity of the heaviest 1% of precipitation days for the 1981 to 2010 climate normal period compared to the 1951 to 1980 climate normal period. So it's the change between those two periods. The red dots are increases, blue dots are decreases, and you can see there's a lot more red than there is blue. And the larger dots mean that there's a higher percent change. So these large red dots that you see all over the region correspond to pretty major increases in precipitation intensity over the last few decades. Now, these are all region-wide climate trends, but what we actually feel is impacts at the local level. These are what we have to prepare for and adapt to. So I'll go through some of the major impacts, but this is not in any way an exhaustive list of every single one. But one impact that gets a lot of attention in the Great Lakes region is that of harmful algal blooms, because they affect all coastal regions and they negatively impact human health, ecosystem health, and local economies. Over 500,000 people in Toledo were left without clean water after the harmful algal bloom in 2014. So algal blooms form when nutrients like phosphorus run off into the lake from agricultural lands and then sit in warm, shallow surface waters where algae can feed and grow. Now, algal blooms have been happening for many years. They're not caused by climate change, but they are enhanced by some of the regional changes in temperature and precipitation that we're seeing. Some more rainfall, and specifically earlier shifts in spring rains and extreme events, increases runoff from farmland, which then increases the phosphorus loading in the lakes. This is coupled with warmer water temperatures that cause there to be less returning in the lake, so more stratification. And this leaves those nutrients to just stagnate in warm, shallow water for algae to feed off of and grow out of control. And that is why this is such a problem in Lake Erie or the coast, and not so much a problem in the northern Great Lakes that are deeper, colder, and lower in nutrients. These algal blooms use up all the oxygen so that there's none left for fish, creating hypoxic dead zones where no fish can survive. Changes in temperature and precipitation patterns have widespread impacts on forests, agriculture, and wildlife as well. As we see warmer temperatures, we will see forests start to migrate northward. And though it probably won't happen in our lifetime, a lot of tree species that have been in certain areas for centuries will be displaced by trees that are more suitable for the new state of the climate. And while some tree species will be able to adapt and migrate with the shifting trends, some will be unable to migrate fast enough to keep up with the pace of climate change. And similar to forests, many species of mammal, bird, and fish will be migrating northward following shifts in temperature and precipitation. And some will not be able to adapt or move fast enough to keep up. So we will be seeing declines in biodiversity, as well as smaller cold water fish populations as the Great Lakes themselves also form. And we've already touched on the longer growing season, which is a slight benefit for agriculture. But like I said, these benefits will be outweighed by things: warm spells, droughts, late spring freezes, water scarcity, flooding, just a lot of cons to outweigh the pros. Climate change really just brings a lot more uncertainty to the table than we are used to, and we need to prepare for unpredictable events. And I also want to touch on water levels, because that's something we do hear a lot about and get a lot of questions about, especially with the very high water conditions these past several years. Water levels in the Great Lakes are mainly driven by precipitation, evaporation, and runoff. So unlike the oceans where sea level is expected to rise as global temperatures warm, Great Lakes will not just rise or fall or go one direction. They will continue to fluctuate as they always have. But with regional shifts in precipitation patterns and temperature, which will in turn impact evaporation, we can expect to see some effects on water levels, and we most likely already have. There will still be periods of highs and lows in the future. The question is more, how will the changes to the hydrologic cycle affect those fluctuations? We saw over a decade of low water levels in the mid-2000s and 2010s, which is mostly from low precipitation, low ice cover, higher evaporation. But then we saw heavy precipitation bring average water levels on Lake Ontario up to flood conditions in just 6 months. And then most recently, 3 of the Great Lakes broke their all-time high water level records in just the last. So while there's not an answer to will water levels in the Great Lakes increase or decrease on average in the future, what we can expect to see is increases in variability with more rapid fluctuations between these 2 states. Changes in water levels can have damaging impacts, whether the water is low and can lead to issues in boating, tourism, and shipping, where marinas and canals have to be dredged fairly often, or if they're high and they lead to flooding and shoreline property damage with erosion, or if they don't fluctuate enough and can damage coastal wetlands that host breeding zones and ecosystems. And then ice cover similarly impacts regional recreation and navigation, with ice cover protecting certain fish species and wetlands, and then providing a platform for ice fishing and other winter recreation. Now, the average Great Lakes ice cover has declined since the 1970s, but like lake levels, this is not a linear trend. Even though ice cover has decreased on average, it will not necessarily always be low. There are still some years like 2014 and 2019 when we had polar vortex intrusions that caused almost full ice cover. These years had weak Arctic circulation around the North Pole that allowed for some cold Arctic air to escape southward and give us extremely cold and snowy winters. So even though we're seeing less ice cover on average than in previous decades, there will still be some individual years of high ice cover due to natural variability like these polar vortex years. Ice cover also influences water levels. Typically, low ice cover means more open water, which leads to more evaporation from the lakes through the winter, which causes water levels to be lower the following year. This is the situation we saw for quite a few years in the 2000s and early 2010s, before that really high ice cover year in 2014 made the water levels start to go back up. Both water levels and ice cover are important to the shipping industry, but there's not really one ideal state of the lakes and of ice cover. This year is seeing such high water levels that the shipping season is actually delayed by several weeks due to high outflows in the St. Lawrence River. Low water levels cause issues for shipping because vessels have to lighten their cargo, which costs tens of thousands of dollars per trip. But less ice also allows the shipping season to last longer. So you can see pros and cons to multiple scenarios that have fairly significant impacts on the economy. So I want to end on our precipitation impacts, particularly those on stormwater management and local flooding, since that's very relevant to this group. So the increases in extreme precipitation we're seeing can lead to short-term flooding, which can damage roads, bridges, and other infrastructure. So it can interfere with transportation and emergency services in extreme weather. It can cause erosion, especially along shorelines and rivers where the flows or waves increase. And municipalities have combined stormwater sewage systems, so overflow could lead to water quality and public health issues in really extreme situations. Increases in annual precipitation can also help contribute to these problems, even if this precipitation is spread out over the whole year. Think about ground that is already saturated with water when a heavy precipitation event hits. That's a much different picture than if the ground wasn't already saturated. In cities, have to rely pretty heavily on stormwater drainage systems because of all the impervious surfaces, all the concrete. Otherwise, that water would have nowhere to go, but even these systems can be overwhelmed. And this is probably the most immediate, tangible impact of a changing regional climate. And one of the bigger reasons that different cities and areas are now pursuing adaptation efforts and looking into their stormwater infrastructure to respond to this. A lot of older stormwater systems were designed based on historical conditions and don't necessarily have the capacity to handle these larger volumes of rainfall in a shorter period of time that we're seeing happen more and more often. And at the heart of it, that's what adaptation is, being educated on the risks and changes so that you can plan and prepare for them and make the necessary changes now so that when they do happen, the fallout or the recovery won't be quite so tough and expensive. Here's a few examples of things that have happened in the past several years that have motivated action. In the upper left, there's a picture of a road wiped out on the Bad River Reservation in northern Wisconsin after a series of thunderstorms caused extremely severe river flooding, infrastructure damage, and cut off the main roads to get supplies and food and water. The Bad River Band actually came to us to ask for some localized climate projections so that they could incorporate into a pre-hazard mitigation plan to assess responses and preparedness to all sorts of potential extreme weather events like this one. And then the bottom right photo is of the US National Guard setting up sandbags around Lake Ontario shorelines that unfortunately don't seem to be particularly helpful in this picture. This was during the Lake Ontario floods of 2017. And these floods were the result of sustained heavy spring rainfall over the Ontario basin that caused water levels on Lake Ontario to rise to record levels and flood shorelines all across New York and Ontario, Canada. This was such a costly event that communities along the Ontario shoreline are now taking action to better understand their risks and planning for similar events to occur again in the future. We're working with a few partners on a project in New York right now that is assessing economic impacts and vulnerabilities to flooding from high lake levels. And I want to end by talking about an ongoing project that we are facilitating. It's called Adapting Great Lakes Stormwater Systems to Climate Change, and it is intended to help cities prepare for climate change by creating a universal vulnerability assessment template and training cities on how to use it to develop their own assessment. The need for such work arose from a number of factors, one being what you already know, that increases in precipitation that can overwhelm many older stormwater systems. The other being that many small and mid-sized cities in the region just lack the capacity to do much about this. Unless you're a very large city with lots of staff and funding, there may not be a lot of resources and personnel at your disposal to even evaluate your vulnerabilities to climate change, let alone potential solutions or adaptation plans to prepare for it. This also ties in with the lack of access to climate information, which can impede cities from influencing hazard and climate-related actions to increase their resilience. This is where the need comes in to support the implementation of climate information into community-level planning. And then on a more social science side, this project also aims to develop strategies to scale up this effort by testing different engagement methodologies, but I will not get into the weeds of that part today. This work was focused on creating a universal vulnerability assessment template, specifically focused on stormwater systems, and developing training materials on how to use it. The goals of this were to help mainstream the adaptation process and reduce the cost of scaling up. The templates are pre-populated with localized social information from the last US Census, as well as customized local climate information on historic trends and future projections. In the trainings, the cities were introduced to climate vulnerability and resilience, walked through the different chapters of the template to understand the information and the process, and then prompted with guided exercises to help get them started on assessing the sensitivity and adaptive capacity of their different stormwater system components. And just to give you a better idea of what I mean when I say stormwater system components, here's some examples of the components identified by cities during the trainings. We had quite an array of examples across the different cities. Some looked at infrastructure, like their combined sewer systems, their stormwater pipes and water treatment plant. Others looked at streams, flood-prone neighborhoods, street trees, and floodplains. So these are the kind of specific things that they evaluate as part of the vulnerability assessment. So this is still an ongoing project, and it's with 12 cities in the Great Lakes, but we're already looking forward because we have a pretty big project to scale this up for 60 cities in the Gulf region. There will be far more people on this 3-year project to make it cool. And the end goal in all of this is to make this a more universally accessible tool for any city to be able to pursue climate resilience even with limited resources. So I hope you learned something new today, either about GLISA or about climate trends in the region, or just about some of our projects and things that other cities in the region are doing. I'd be happy to answer any questions. Don't hesitate to reach out to me via email or refer to our website to learn more and find any of the data and information that are presented in the slides all on our website. So thank you so much for your time.
All right, thank you, Kim. And there will be time for Kim and the rest of the panel to answer questions in about 30 minutes. So as sort of the inverse of Kim Channel, Robin Wilson, instead of having 2 degrees from the University of Michigan, has 2 degrees from Ohio State, her master's degree and PhD. We'll be bringing up her bio in a second here on the screen. But I do want to mention that when we first started working together back in August with professionals from the Water Management Association of Ohio and the Ohio Water Resources Center, as well as multidisciplinary students from TerrAqua And we knew the World Water Day theme was going to be how water and climate change are interrelated, and the interrelationships between those two. And we felt that a topic around communication would be very important. And we sort of agreed quickly that communication would be a topic we'd consider. And then the nomination to request Dr. Wilson to present as part of this topic was unanimous. We all felt very strongly that Dr. Wilson would be a great fit. So without further ado, we will hand it over to Dr. Robin Wilson. Thanks.
Great. Thanks, Joe. Go ahead. Oh, it says I can't share while the other participant. Oh, there we go. Okay. Hopefully everyone can see this. Someone will text or message me if that's not the case. But yeah, thanks for having me today. If you caught that bio quickly, I'm a behavioral decision scientist. So a lot of the work that I do is looking at decision-making under risk and uncertainty. So one hat that I wear on occasion is risk communication and science communication. A lot of my personal research is in the context of climate adaptation and managed landscapes. So I do some work on wildfire and kind of how we manage public lands in order to avoid some of the biggest impacts of the kind of increasing frequency and severity of wildfire in that landscape. And then the majority of my work is really focused on water quality in the Great Lakes and thinking about largely agricultural landscapes and how we might manage those landscapes to avoid some of the biggest negative impacts downstream on the lakes. And as was pointed out just a bit ago, there are changes happening in the lakes and in the climate of the region that we have little to no control over in the short term, at least. And so the one piece we have some control over is really human behavior, right? And the decisions that we make across rural and urban landscapes. And so that's a lot of where my work has focused. So when I was asked to speak to kind of communication, water, climate change, what I thought I would do is take more of an adaptation focus, given when we think about water, a lot of this is focusing on water quantity and water quality, and how do we manage changes in both of those spaces given climate change. And so I'll focus a bit more on adaptation, but I did want to kind of talk broadly about some of the things we've learned about how we communicate in the context of climate change and how we might engage not only the public or kind of stakeholders that may be less involved in kind of community level decisions, but also how might we engage decision makers or folks in the government or other sectors who are involved in things that we've also talked about this morning already, like stormwater management. So I'm going to try to cover a broad range of things. So hang in there with me. This is, a semester's worth of a climate communication class in about 30 minutes. So I will try to move through this as quickly and clearly as I can. So I wanted to take a step back and just say that from a communication standpoint and even a perception standpoint, that it used to be when we thought about climate change, these were the sorts of images that came to mind. We've heard a bit about melting glaciers this morning. Certainly the polar bear and the sad polar bear floating on his little piece of ice remnant is something that has often come to people's minds and even been used as kind of a symbol of climate change. We might think about drought, we might think about faraway places, people in faraway places that are different from us. And for a long time, that was really a negative for communicating climate change, because what we did is we essentially convinced people that climate change was happening far away to people elsewhere in ways that was not relevant to us. I would argue, though, that in the last maybe 5 to 10 years, this has started to become more of the norm when people think about climate change. So we see evidence that as the general public and other stakeholders think about climate, instead of focusing on polar bears and melting glaciers and drought in faraway places, we are starting to realize that the impacts of climate are personal, they are local, and they are happening here, not only in the Midwest and in the Great Lakes, but across the United States in general. So we have our wildfires and floods. The top two images just from this past year or two are two of maybe the most salient things that people think about depending on where you live. Certainly a lot of the research on climate adaptation from a household and even municipal level has been on flooding. And so this issue of kind of water management has certainly been at the forefront in a lot of even the academic research. And then we have these fluctuations, right, in times of drought, heat waves. Certainly another one that I think is starting to come onto people's radar is the spread of vector-borne disease. So as we see more Lyme disease, for instance, kind of move from what was typically most prevalent in the Northeast, but kind of moving west across the country. This is another one of these impacts of climate change that we have to now address, and we have to start to adapt. So I would say that we have shifted a bit away from kind of thinking about climate as an abstract, distant problem to a very concrete, near local sort of problem, which is a good thing, because from a communication standpoint, this is one of the kind of key lessons in communication in general, but climate in particular, is that people won't be motivated to do something about it unless we start to think that it's happening to us now in ways that are meaningful at a very local level. And that's what's great about the RISAs and some of these other efforts, is to take what maybe was thought of as a global sort of issue and downscale it in a way to make that science more meaningful for local and regional contexts. So when we think about responding to climate change, so we now have this kind of vision of climate change that's more local. It's focused on more frequent and more severe climate exacerbated events like fire, like flooding, like sea level rise. And so we can respond in three really key ways, right? And so the first way that we often think about responding to climate change, and you can think about this from a mitigation and an adaptation standpoint, I'm kind of framing it in the context of adaptation. But the first thing we think about are technological solutions, right? So this would be in the context of flooding, installing or improving levees to hold back floodwater, right? And so this is one thing we might think about. In the context of mitigation, we might think about geoengineering, right? We might think about things that we could do to address climate change at a broad scale, but also reduce the impact of some of the hazards that we're experiencing. I would argue as a social scientist that we've relied on these solutions a lot in the past to solve environmental problems. And then often that comes back to bite us as we realize there are some things that we're kind of overlooking when we focus too much on technological solutions. So I would argue that this is treating perhaps the symptom, not the real cause of the problem. The cause of climate change is human behavior, right? So we know this is anthropogenic climate change. And so when we focus too much on technological solutions, we're bypassing the human behavior that is at the root of the problem. And even in the case of flooding, this is an interesting story from just this last year, where this law professor at University of Florida is arguing Midwestern flooding isn't a natural disaster. The hazard itself is not the disaster, it's our habits and our building codes. So if we choose to develop in floodplains, that's the real issue that needs to be addressed. We don't need better levees to protect the development in the floodplains. We need to not be in the floodplain in the first place, right? So it's just an important question to ask. Certainly there is a place for technological solutions, but again, as a behavioral scientist and a social scientist, we often look at those solutions and go, are we just bypassing the real core, the real cause of the problem? And do we need to make a different type of decision or implement a different set of solutions? So when we move away from technological solutions, there are kind of two categories of solutions that are out there. One are these kind of structural solutions, I'll call them. This is things like regulation. These are incentives. These are changing the kind of default option that are available to people. In the context of water quality, which is a lot of the work that I do, we rely almost solely on voluntary programs to engage farmers in conservation that are incentive-based, right? Where there is some sort of economic incentive meant to offset the short-term costs, at least, of those changes in practices. The assumption being that by offsetting some of that short-term cost, we'll get more farmers to participate. There's talk, certainly in the Great Lakes, of should we move away from those voluntary incentive-based programs and into regulation, right? These are both structural sets of solutions, meaning that they are, one, directly treating the root cause of the problem. So they're treating the human behavior or the decisions that are really driving either climate change at its core from a carbon emission standpoint, or in the case of the Great Lakes, water quality challenges. And so when we're engaging in a structural solution, we're trying to alter the costs and benefits of different actions through changes in the kind of decision-making environment. So this could be the physical environment, the social environment, the political environment, which would be regulation, or the economic environment, which would be incentives, right? And so this is certainly a class of solutions that we, again, have relied on a lot in the past to address environmental challenges. There's a third set of solutions that I will call the cognitive solutions. So this is where we might message. This is the classic kind of space for communication. where we're trying to make maybe the impacts of a problem more relevant, or we're trying to make the solutions more convincing. Here's a quote from our former president, Barack Obama: "Climate change is no longer some far off problem. It's happening here, it's happening now." This is a very standard strategy in climate communication, again, to try to convince people. This isn't something we can just ignore as happening elsewhere, but it's happening here. And this is a very standard form of messaging where we're trying to make those impacts more relevant, right? And so here I would say we're still treating the root of the problem, but we're treating it perhaps indirectly. So instead of putting kind of constraints in place through regulation or incentives in place through kind of economic programs, here we're trying to alter the beliefs that somebody holds about the problem or about the solutions that are available, with the idea being that that can also change behavior, right? So in the case of regulation and incentives, a farmer, for instance, who decides to put a conservation practice in place might not really believe that it's important, may not believe that it's his or her responsibility to do that, but if there's a good economic incentive in place, they may go do it, right? And so those structural solutions don't require that people change the way they think about a problem, the sorts of beliefs that they hold. Cognitive solutions do, right? So here we're saying, okay, what are some of the problematic beliefs? What are some of the things that we would like people to think differently about? And if we change those, we can see what sort of an impact that might have on the decisions that they make. So again, from a cognitive solution standpoint, this is squarely where improved communication falls. And so what I want to do for the rest of our time here this morning, for about 30 minutes or so that we have left, is to think about how we implement those cognitive solutions. And like I said, there's so many things we could talk about here, but I'm going to focus on really 3 different pieces. First is communicating with the public about climate change. So broadly speaking, there's been a lot of great research on how do we communicate about climate change. And that research has shown that there are 5 really critical beliefs that people have to hold in order then to go and do something about climate change, right? And this might apply both to mitigation and to adaptation, but it's this idea that people who are actively engaged, either at a personal or household level, or maybe in a political way, do hold these 5 key beliefs. And I'll talk about what those are and some of the strategies you might use to communicate about those. The second thing I want to talk about is kind of going a little bit beyond those beliefs. So what do we know about motivating household level adaptation? There was a recent meta-analysis that came out this past year that basically summarized all of the kind of household level studies that had been done on climate adaptation specifically. Again, a big focus there was actually on flooding, since that has been kind of one of the most obvious and prevalent, maybe climate exacerbated hazards, not only in the US, but also worldwide. And so these studies do consider those beliefs to some degree, but also look at what other sorts of things might be influencing people's decisions. And so I'll highlight some of what we know there. And then the third piece that I want to talk about really comes out of a National Academies workshop that I helped organize several years ago. It was a workshop on characterizing risk and climate assessments. And so I think, again, is kind of consistent with some of what we heard earlier in terms of how GLISA is focusing the way that they share the science about climate. But if we want to engage decision makers in risk management, we need to shift kind of the way we talk about climate change and the type of information that we provide. And there were several conclusions that came out of that workshop. You can access the report on that workshop on the National Academy's website. I can provide that link later. I also have a reference on those slides to a scientific paper that we put together kind of summarizing that workshop. But essentially the takeaway there was we need to have more of a decision focus than just a kind of climate problem focus. And we need to more carefully frame info on climate impacts around worst case societal consequences. So we have to move away a bit from the climate is changing and we need to do something, to what specific problem do you have as a decision maker? What info do you need in order to address that problem? And how can we provide that information from a climate assessment standpoint? So I will attempt to walk through these 3 things, and hopefully we'll still have plenty of time for questions for myself or for other speakers as we wrap up. So when it comes to communicating with the public, like I said, there's been a lot of great research in this space. A couple resources I wanted to point out to you. The Yale Program on Climate Change Communication and also the George Mason University Center for Climate Change Communication are two of the main kind of academic centers that have done really excellent research on what does the public think about climate change, how do they feel about it, how has that changed over time. You can access really great maps where you can drill down to a county level, and in your particular location, this is on the Yale website, you can see what the beliefs are in that county. And then the paper that I have cited here at the top, The Genesis of Climate Change Activism, it talks about these key beliefs and how they are very excellent predictors of people engaging in particular in political action. And so the beliefs are this, one, that there is a scientific consensus. So the research often refers to this belief as a gateway belief, meaning first people have to trust the science. First people have to buy into the fact that there's a consensus. And then once they do that, they have to buy into these four things: that climate change is real, that climate change is caused by people, that climate change is bad for people and not just people elsewhere, right? But here and now, for me personally, in my local area. And fourth, that climate change is solvable. And the people who believe in the scientific consensus and then believe that climate is real, caused by people, bad for people, and solvable, these are the people who are engaged in climate action. And so one of the first things that we need to do, whether this is a member of your local community or whether this is even a decision maker in a kind of higher position of power in terms of decision making at a community level, is we have to ensure that they've bought into these five things. And there's a lot of ways that you can approach this. So when we think about climate change being real, some of the hesitancy that we hear from people is, well, hasn't the climate always been changing, right? And so is there really anything different going on right now? Are we not just in a natural sort of fluctuation? What I think is important to point out to people here, and we can do this thanks to ice core data, which was referenced earlier this morning, is we can show that, yeah, the climate has always been changing. These are carbon dioxide concentrations on the y-axis, but you could replace this with temperature and it would look similar, right? Because there's a very strong correlation between carbon dioxide and temperature. But essentially, yes, the climate has always been changing, but look at what has happened in the last 150 years, right? What we need to make clear to people is that we are in a period of unprecedented and accelerated change. Right? So even over the last 10,000 years, global temperatures have been generally stable, right? They've ranged about 2 degrees warmer or cooler than today. But small changes equal big impacts. Another thing we hear is people say, oh, well, what's a couple degrees, right? We talk about average global warming of 2, 3, 4, even 9 or 10 degrees, and people think, that's no big deal. I mean, later this week in Ohio, we're gonna get a 30-degree swing, right, in temperature, I think, from Friday to Saturday. And so that doesn't seem like a big deal to people. But putting that in the context of what those changes have meant in the past can be really powerful, right? So 20,000 years ago, we were in the most recent ice age and global average temperatures were just 9 degrees cooler than today. And we had miles of ice piled on top of some of our major North American cities, right? And so helping people understand that the climate has been generally stable, especially under kind of human civilization. It is not stable now. And what seem like small changes can have a really big impact. And those are some of the key messages that I think we have to get out there to help people understand that what's going on today is something different than what we might have observed in the past. The second piece, right, is not only is it real, but this current unprecedented change is caused by people, right? And one of the things you hear here from a lot of people is that, well, yeah, so there's a change happening right now. Maybe it's different than what we've seen in the past, but how do we know it's really caused by people? Well, of course, there's excellent data that helps us kind of look at what might explain the change that we're experiencing. Is it a series of different natural drivers like volcanic eruptions, changes in the Earth's orbit, solar radiation, even from the human driver's side? Is it greenhouse gases or is it something else? Is it changes in land use and land cover? Is it changes in the ozone layer or in aerosols that we've produced? And there are great visualizations for this. One that I love, you can get on Bloomberg.com if you just Google what's really warming the world. And it basically shows you this graph, but breaks it out and you can kind of watch and map out what the temperature difference would be from average when we account for each of these different potential sources. And what we can see is that our best explanation for what's been happening and what will continue to happen is when we look at all of this together, but the real driver of it is greenhouse gases. And I think that's important for people to see, because we, often hear there's other explanations, but we have good data, and we have some great visualizations that make that data very friendly to people, to help us observe and see that no, it's really the human drivers that explain this current trend. Part of when we get into climate change is real and caused by people, this is where you can bring in this message about the scientific consensus. The language that you see on the screen right now is actually tested language. It is the most effective language to talk about the scientific consensus. So based on the evidence, 98% of climate scientists have concluded that human-caused climate change is happening. We also know that visuals like this little simple pie graph are very meaningful to people. And so making sure that people really understand that. One of the problems we've had probably in the last several decades is that a practice in the media, and even if we say cable news and the bias that we see in cable news, but a practice in the media has been to cover both sides of a story, right? By covering both sides of a story, it makes it seem like there's a 50-50 kind of split in what people think. The reality is that's not what it looks like for climate change. And so people have sometimes been given the impression that there's more disagreement, right? Or more of a kind of equal split on what's going on with climate than there actually is. Another thing that we know is that scientists are still a fairly highly trusted source of information in the United States, globally, but in the United States in particular. An important part of communication is certainly figuring out who is the source that a particular group trusts. Scientists aren't a bad one to start with. One you don't want to start with is the government. When we look at Pew data from the 1950s to today, trust in the federal government was about 80+% in the 50s, post-World War II. Trust in the federal government in the US is now down to about 18%. So we've seen a steady drop over the last generation or two in trust in the government, but we do see, again, a lot of trust still in medical experts and scientists. And so getting this message out there is important. But what we do need to recognize is that it may not just be scientists that people are looking to understand if there's a consensus, but they might be looking to other sort of social groups that are important to them. What's great is when you start to dig into religious communities, you see that almost all, except for I think maybe the Southern Baptist Convention, have come out with a climate statement. The Catholic Church has a climate covenant. The Pope has been very outspoken about this. Here's a reference to the Dalai Lama urging the world to act on climate change. So when we look at religious and faith leaders, we see a lot of support for the fact that human-caused climate change is happening and that we should be doing something about it. We also see this among maybe groups in the private sector that we wouldn't imagine would be outspoken about this, right? AEP, our kind of local energy provider, takes a pretty strong position on climate change and actually does a lot to encourage efficiency in energy use. Dell, Walmart, right? There's a lot of private companies out there who have been very public about their concern about climate change and the actions they're taking to address it. And something, again, that resonates with some groups in particular is the idea of national security. And so this was all the way back in 2009, but the Pentagon and the CIA identified climate change at that time as one of their new emerging threats. So severe weather events will increase in intensity in the future, and this creates a real problem for national security. So again, it's important to think about your audience and your group and what's going to matter to them and who are they looking to as their kind of opinion leaders. And anywhere you look, there is a pretty solid consensus among a variety of groups, from the scientific community to the faith community to the business community, to even various aspects of our government that we may not thinks about this as much, that this is a problem we need to address. That third belief, right, is climate change is bad for people. So again, we have to move away from this issue that climate change is bad for glaciers and bad for polar bears and bad for people in faraway places, but it's bad for us here and now. These are some of the key messages that have been pulled out for the Midwest from the National Climate Assessment, and you can go and read more about that. And so we need to focus in on what is our group going to be most concerned about. We expect some, and some of this was covered earlier, but strong impacts to agriculture, to forestry, to biodiversity and ecosystems, to human health, to transportation and infrastructure, and to particularly vulnerable communities. And so again, depending on what resonates with people and what's motivating to them, you need to drill down and figure out which of these messages is going to be most important, and how can I translate what we know about climate impacts in this sector in a way that's going to be really meaningful. So I'll just give you a quick example of agriculture to kind of put that in context. We just did a survey that late this last summer on climate adaptation across the Eastern Corn Belt with farmers. And so instead of just talking about, oh, the climate's going to get, I think my friend Erin Wilson at Bird Polar says warmer, wetter, and wilder. So instead of just saying that generally or talking about what some of those changes in temperature and precipitation might be, what we did in that survey is we actually boiled down those expected impacts at a local level in terms of changes in planting and harvesting dates, and then total rainfall during the growing season, right? So it's not enough just to say, oh, ag productivity will be reduced to 1980 levels without technological advances, but what does that mean for an individual farmer? They need to know how that planting date is going to change, how that harvesting date is going to change, and how the amount of rainfall and when it falls is going to change between those 2 dates, right? That's what they need to know to make better decisions. So we need to really drill down to that level and provide information at that level of detail for people who are grappling with these challenges. So I said the fourth thing is that not only do we have to believe it's happening and it's caused by people and it's bad for people, but that it's solvable, right? We don't want to leave people with this feeling that, oh, there's nothing we can do, throw our hands in the air. And so we do need to talk both about adaptation and mitigation, right? So again, I would say until recently, there was a lot of hesitancy to even talk about adaptation, the fear being that if people are convinced we can just adjust to these new conditions, then why would we ever reduce our emissions or try to mitigate the bigger problem, right? And so that was a fear for a long time. I think that fear has gone away for maybe one of 2 reasons. One, recognizing we just can't do that anymore, right? We need to adapt and mitigate. So we can't ignore the adaptation side anymore. But interestingly, there's been some studies that have come out recently looking at kind of spillover effects from adaptation to mitigation. So specifically one that comes to mind, and again, I can provide this reference, I don't have it on the screen, is that in the context of sea level rise, as people in coastal communities become more concerned about sea level rise and start to think more about what they can do as individuals or what their communities can do to reduce that vulnerability, while they're focusing on that, they're simultaneously basically adjusting their thermostats at home, right? So by talking about the need for adaptation, by talking about climate exacerbated impacts, by engaging people in these conversations around community preparedness, that often spills over into kind of household level energy decisions where people go, oh, well, also maybe I should do this other thing, right? Maybe I should reduce my energy use, reduce my impact on the climate from a kind of larger standpoint. So I don't think we need to be worried about adaptation replacing the need for mitigation. One, we can't afford to not talk about it. Two, there's evidence that there are some positive spillover effects from engaging people in adaptation conversation to seeing them then mitigate as well. So the last 2 things I want to talk about is kind of going beyond just those 5 climate beliefs that we know are really critical, and what sorts of things do we need to address there. What else do we know about engaging people in action? Again, whether that be adaptation or mitigation. At a broad level, in social science, we think about all of these things that influence individual decisions, right? And so I have a kind of simple graphic here saying that sometimes we think about things that are unique to the person, right? That individual's knowledge, their values, the beliefs we just talked about. And then sometimes we think about things that are not unique to the person, but might be unique to a particular community or a particular context, right? And these are things that kind of exert pressure on individual decisions, not from the inside out, like our knowledge and our values, but from the outside in. And this could be things like the physical environment and what it allows us to do or not to do. This could be things like economic incentives and how that might encourage people to behave in certain ways, right? And so when we talk about all these influences on individual choices, these align pretty well with this idea of cognitive and structural solutions, right? So we can think about what are the things we have to change that are internal to the person, that are these cognitive sorts of solutions to behavior change. And we can think about these things that are external to the individual, which essentially inform these sorts of structural solutions. What might I have to change in that individual's environment or that individual's context to encourage them to make different choices? And so again, we could, go all day about how these different pieces play out, But I mentioned there was a meta-analysis that came out recently looking at household level adaptation. So again, this isn't kind of municipal level decisions, but this is looking at individual households. And this was a study looking globally at research that's been done in this area. And they found 106 studies that have been conducted in 23 different countries, examining 13 motivational factors, some of which kind of fall in that internal kind of cognitive bubble, some of which fall in this more external structural bubble. But what they found, and again, these studies are largely focused on flooding. You can look at this paper and you can see the different climate exacerbated hazards that are studied, but by far the focus has been on flooding. And what they see is that adaptation is most likely with high social pressure. So when an individual feels like others that they care about and whose opinions they value expect them to be doing something about climate from an adaptation standpoint, when those individuals are very worried about those climate exacerbated impacts, and when they believe they have the ability to take action. And so you can see aspects of this that align, I think, with those climate beliefs, right? Fear or worry is basically saying that this, the impacts of climate are personal and relevant to me, they're bad for people. The ability to take action is in line with this idea that it's solvable, right? And so we're seeing some of those beliefs kind of pop up here. But one that's interesting that comes more from outside that bubble is social pressure, right? And humans are social creatures. And unless we see in our kind of social environment that others are doing these things or that others expect us to do it, we're much less likely to take action. Interestingly, what they found in this study is that one's kind of knowledge about climate change or their knowledge about climate exacerbated impacts did not have a significant effect on their likelihood of taking action, nor did their past personal experience with that hazard. Two things we might expect to have a positive effect, but they did not. And so again, there is some good research out there. We are starting to kind of summarize that research and get a better idea of what really matters when we're motivating people. So the last piece, I just want to briefly touch on this because I want to expand beyond kind of general rules for communicating with people, right? From kind of individual members of the public up to even kind of high level decision makers, into kind of this different perspective of thinking about engaging decision makers, whether this be kind of farmers making adaptation decisions, whether this be mayors and governors, right, making adaptation decisions on behalf of the city or the state. And so these are some takeaways that are highlighted in this paper in Environmental Research Letters, which again is a summary of this National Academies workshop that I helped organize, which is really saying, you know, we've got to move away from the way we usually assess the science around climate change and make it more risk focused. And there's really three takeaways that we highlighted in this workshop and in the associated products. One is we have to start with a decision focus, right? So we have to shift from making this general kind of case for action, right? Climate change is happening, we need to do something about it, to characterizing very specific risks to help people pursue very specific actions. So again, I'll call up that example I gave of farmers and adaptation in the Corn Belt. We can't just say it's warmer, it's wetter, it's kind of warmer at night, we're gonna have more rainfall overall, but it's gonna vary throughout the year. We need to be more specific than that, right? We need to say, here's the likelihood that your planting date shifts a month later. Here's the likelihood that your harvest date shifts a month earlier. And this is what your growing season is going to look like, and this is how much rainfall you're going to get. And we expect this to be the case 8 out of the 10 next years. What do you want to do about it, right? And so we need, again, move away from these broad generalities to these more specific assessments of risk for very specific actions. Second, we need to improve the information we give for choices about the risks. So again, move beyond just the risks of the biophysical events to the risks to human well-being associated with that, right? So it's not just about the wildfires happening more often. It's not about them being more severe. It's not just about the algal blooms happening more often and being more severe, but it's translating those events into what that means for human well-being, public health, the economy, right? Recreation, the sorts of things that people care about. And we're doing a better job of that, but we could do better, right? I make this case in agriculture for water quality a lot, that we don't translate the sorts of things we're expecting people to do into really clear economic metrics. And unless we can do that, that's not going to be very meaningful to a lot of farmers. We also need to focus more on extreme events. So what are these unprecedented events that were unthinkable? We're seeing this right now with the wildfires in Australia, where climate models didn't even predict that that scale of fire could happen until the end of the century, right? And so our models were probably wrong, but these are unprecedented events that were not only unthinkable, but weren't even showing up in the models. And that's what risk management is, right? So sometimes we focus a little bit too much on kind of what we know the most about, and we don't think about the tails of the distributions, right? Which is where these extreme events happen, and this is what we have to manage for. We're experiencing this right now with the global pandemic, right? So unless we start to think about those extreme events, we will be ill prepared and people will be very negatively impacted. And then the last piece, and there's a lot of more detail on this in the environmental research letters paper, we have to frame risk information more strategically. So we need to present these risks in familiar and impactful terms. So in kind of flood management, the 100-year flood is a standard sort of kind of metric people think about. So explaining to people that the 100-year flood will increase from once every century to once every decade, right? The magnitude of those events is going to happen now once every 10 years instead of once every 100 on average, right? And so finding what terms are useful and meaningful to people and using that to talk about the changes that are happening. And using visuals wherever possible. Sometimes we have a tendency in kind of scientific communication to focus too much on the numbers and not do such a great job really making those numbers meaningful and kind of emotionally impactful for people. And so figuring out what sorts of visualizations and whatnot are available to communicate these changes can be really critical. And I think I'll just skip past this. This is just key questions you can ask when engaging decision makers. So what do you value? What do you wish to avoid? What keeps you up at night is one that I like a lot. And then when it comes to assessing societal risk, what is increasingly likely to happen that puts things of value at risk? How bad could it get? What outcomes can't we rule out? What tools and approaches and methods are available to manage those risks? And what efforts might be needed across different timescales? These are just some of the important questions we have to be asking, not only in terms of understanding what people care about or what type of information they need, but also how we might provide that information. So I'll just wrap up and we can move on to our Q&A. So we can no longer ignore the impact of climate change or the role of human behavior in solutions. A desire to take action hinges on holding 5 key beliefs, and this is that scientists agree that climate is real, caused by people, bad for people, and solvable. Actions will be most likely when the risks are perceived as personal and the solutions doable and socially expected. Right? And so we see a lot of evidence that it's not just these 5 key beliefs, but add in this social expectation and this modeling of socially appropriate behavior. And that has a really big impact on what people are willing to do or not do. And again, I think we could draw lots of really cool parallels to what we're experiencing with the pandemic right now. And then finally, better engaging a range of decision makers requires a shift toward characterizing the risks for specific values of concern and actions, and better communicating the societal consequences associated with extreme events. So pushing ourselves as far that way as we can, I think, will really aid in decision making. So I will stop with that. Again, you're welcome to email me for additional information on any of this, and I can provide links and resources to Joe and the team as well.
Great, thank you, Robin. We are now moving into the Q&A session. We have about 10 minutes set up for that. Before we do start taking those questions, I do want to hand it over to Eugene Bragg, who's going to answer one question that's already been asked.
Thank you, Joe. So in reply to a question asked by Hannah, Michael said, great question. I do not anticipate that the Great Lakes states would have to share or donate water to Western states. I'm not sure there is a legal mechanism federally to enforce that. And then he wisely advises to ask Professor Carlarn at the law school. I wanted to add something, though. There is a legal mechanism. It's called the Great Lakes Compact. The formal title is the Great Lakes St. Lawrence River Basin Water Resources Compact. Was negotiated and enacted by the Council of Great Lakes Governors in 2008. It is a mechanism for states to hold each other accountable with Great Lakes water withdrawals. So each state had to reply in kind to create state law, and it has been expanded and is now managed by the Conference of Great Lakes and St. Lawrence Governors and Premiers. So just Google Great Lakes Compact for a good initial primer. Wikipedia has a FAIR page on it, and you can click the links from there to find out a lot more about the legal mechanisms to prevent excessive water withdrawals from the Great Lakes.
Thanks, Eugene. I'll turn to one of the questions that was posed in the chat, and I'll ask Mike, Kim, and Robin to see if they can prepare a response to this. This is from Erin Hazelton. She asks, in our region, what would you recommend we, society, do to best buffer extreme precipitation events? Build wetlands, reduce channelization in ditches, reduce impervious surfaces. Do you see any communities in our region taking action? And if so, who is leading the effort?
I could jump in. I think I saw someone might have typed a response to that too. I was peeking at the Q&A, but I can jump in and maybe speak more to the rural than the urban side for that. But certainly what we're seeing on agricultural landscapes is a need for more water management. So there's, a big focus on a variety of things that farmers could be doing to reduce the downstream impacts on water quality, whether that be the Great Lakes or whether that be kind of urban water systems, because certainly we're seeing the impacts in both directions. But one of the things we've really focused on there is that we need more subsurface application of fertilizer so that there's less potential for those nutrients to be lost during a big rain event. But doing that is not enough, right? So we also need to be managing that water, knowing that it's going to come often too much at the wrong time, not enough at other times. And so we can't expect to mitigate those kind of water quality impacts and even the kind of water quantity impacts when we think about kind of mini droughts in the summer from an agricultural standpoint without better managing that water. So that might be drainage water management systems on agricultural fields where we hold back the water in the spring. That could be kind of irrigation ponds that are built where that water gets routed and held and then can be used in the summer during dry periods. And that might also mean wetlands downstream and strategically placed where we need more of that water being held back during big events. So those are certainly things that I think are being talked about, at least on the kind of the rural side of thinking about water management moving forward.
Mike, Mike, do you have a response?
No, sorry, I heard that. I heard the echo. I don't have anything to add. I think that's great.
Kim?
Yep, sorry, I think the echo was from me, so I just plugged my headphones in. I could probably add to the more urban side of that, just in some of our experiences and what we've seen cities doing. So I know Milwaukee is really pursuing green infrastructure, things like bioswales that can draw runoff in and filter it. And I think Ann Arbor has been trying to increase their stormwater system capacity through measures like detention basins that allow for more stormwater to pool around freeways and rivers and whatnot. And I know more and more now certain zoning is being reconsidered, especially in terms of building new housing or new infrastructure in areas that maybe during previous zoning were not in flood prone areas, but now are in flood prone areas. And really just evaluating individual stormwater systems because it's different for every location in every city. But I know a lot of issues in the Great Lakes stem from very old infrastructure that was designed around historic precipitation patterns. So that just has to be reevaluated in terms of capacity. And that looks different for every city and every situation.
Okay, so we have time for one more question. And the first question here I'll read off is, more and more apartment complexes and single family homes are being built. Where should we put pressure so that the developers are required to make buildings more energy efficient?
I don't know if anyone's brave enough to take on that question, but I'll give it a shot. You're welcome to save me, other members of the panel. So I would have a kind of larger philosophical response, and I don't intend for this to come across too political, but we've seen a shift in the last couple of years away from federal government leadership on these sorts of things. And there's been a real concern, I think, on the mitigation side of, will we make progress without really strong federal leadership in this space around mitigation in particular? And I have kind of two responses to that. One, it would be better if we had really strong federal leadership and maybe there were things being done at the federal level, changing requirements, right, around energy efficiency and new developments. And that would be great. Not likely to happen, at least in the next year or two, and then who knows down the road. But what we have seen is we have seen a lot of really strong private sector leadership on this. And so there's some folks, Michael Vandenberg is someone who comes to mind, who's at Vanderbilt, who does a lot of work around climate mitigation, carbon emissions, and kind of regulatory and political structures. And if you're interested, he held a workshop recently, and I think there's recordings that are available, but kind of talking about the role of the private sector and how we can engage them and how they continue to make progress from a climate mitigation standpoint in the absence of strong kind of political leadership. So I think, my answer to that question is we need to put pressure on our political leaders to put these sorts of regulations and policies in place. But in absence of that, or until that happens, we are making progress. And I think we can, continue to count on the private sector to provide some leadership there.
Mike or Kim, any additional responses? Okay, that takes us to the conclusion. Dr. Sharp.
Well, thank you, Brian, Mike, Kim, and Robin. We do have certificates as our tradition, although we're not able to hand them out as we normally do. We do have framed versions of them that we will make available to you. And we're doing our best with e-versions of this in the process of trying to develop them. I think Joe's going to show it here in just a moment. So thank you for your participation today. I believe Nicole will be mailing you an officially framed certificate soon. We recognize that the current situation in Ohio and across the world is creating all kinds of challenges for us. In the tradition of the EPN, we're going to be working to provide our networking and educational forums as best we can online for the foreseeable future. If you have suggestions for us, please pass them along to Joe and Nicole. I think this is a time when the EPN, we've built the social capital amongst us all, and this is an opportunity for us to remain connected virtually. And it might be even more critical now than it has been in the past, because as we sort of like separate ourselves, finding opportunities to come together and share is important. So please give us some feedback on what you think could be ways the EPN could support our community and keep things going. There's going to be a lot of distractions and a lot of challenges in the coming months, but I think that we can remain focused on what we can do and supporting you all. So please pass what you want along to us. Here in our school, we have ambitious plans for April with the 50th anniversary of Earth Day coming up. We do have planned a significant program that we anticipate conducting in collaboration with the Sustainability Institute, which is kind of in flux right now in terms of what form that will take, but we hope to be able to circle back and provide you more information about what that program can be. It is a wonderful opportunity to celebrate 50 years since the first Earth Day, and we've surfaced a lot of interesting background material about that first Earth Day here at Ohio State, at least, and we hope to be able to share more in the coming month for that. The in-person elements of these programs will not happen in April, as you're well aware, though we are considering ways to feature some of this content online and reschedule future opportunities. While the remainder of this academic year seems uncertain, but to be clear, students are still taking classes, and we will be having graduation, although whether we'll have a commencement as we always do is still in question. We do have intentions to continue the EPN into the fall, and we're beginning planning on those programs, and we welcome ideas for the coming year. On behalf of the EPN, I appreciate everybody's participation here. Joe and Nicole have done a wonderful job of putting this together. This is probably the last time for another month or two that we'll be actually broadcasting directly here from Cotman Hall. So it's been a great way to facilitate the conversation today, but we'll be adapting next month to a different context of how to do this. I want to hand it out now over to Karina Pagao, Education and Outreach Program Coordinator for the Bird, Polar, and Climate Center, Research Center, who will share some remarks about future alignments between EPN, WMAO, Bird, and other local and statewide partners. Thank you, and please be well.
Thanks so much, Jeff. Hi, my name is Karina Pagao. I work at the Bird, Polar, and Climate Research Center. I am the program coordinator there, part of my plants. I don't have a plant-free wall in my house. I just wanted to talk about some upcoming events that were just postponed to this fall. We were originally supposed to have Richard Alley come visit us to kick off the Bird's 60th anniversary celebration in, actually it's supposed to be this next Thursday and Friday. However, that has been postponed to October 8th and 9th. Richard Alley is a world-renowned researcher, geologist, Ohio State University alum, and he's also the featured host of the PBS Earth to Operator's Manual, which is both a book and a television series. Because this event has been postponed to October, it actually bumps up to what will be a week-long series of climate-based programs that will start October 8th and continue through October 16th. Catherine Hayhoe is a climate scientist and science communication specialist. She's actually really well known, and she will actually be here in October as well to give a series of programs throughout the state of Ohio. So I'm going to attach a link for the Climate Symposium, but also keep your eye out for some upcoming events in October that are related to that as well, and with the Dr. Hayhoe visit. We would love to see you guys in person throughout this week in October, and hopefully at the end of the semester or the summer when things clear out a little bit. If you have any questions, feel free to shoot me a note or reach out to Joe Campbell for any questions as well. And I will again be putting a link in the chat box too. Thank you.
Thank you, Karina. And thank you everyone for participating today. I want to give a shout out to Nicole for all the work behind the scenes and everyone else who helped us today. Take care and be well, everyone.
Yeah, just a few more things before you guys head out. So the student portion we usually have set up for our EPN breakfast will still stay connected with those resources virtually. So I will actually be working with Riley McDonald, Vice President of TerrAqua, to be posting some resources for our March EPN event on our website. So please look out for those resources, students, and hopefully we see you soon for another webinar. Thank you so much for your patience.
Thank you all. Have a good day.